Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the same book Modern Physics by Stephen T. Thornton and Andrew Rex. As usual we first come to its statement. Okay. A muonic atom consists of a muon having mass m equal to 106 million electron volt over c square and charge q equal to minus e in place of an electron. Okay. For the muon in a hydrogen atom, what is part A the smallest radius and part B the binding energy of the muon in the ground state. Okay. Dear students, here Bohr radius applies and then we have to find out binding energy. Okay. Dear students, in order to solve this problem, we will first go through a few snapshots which will help us in reaching this solution. Okay, in reaching this conclusion. Okay. Dear students, this table consists of various a number of physical constants. For example, Bohr radius A naught equal to 0.0529 nanometer, Hc equal to 1240 electron volt into nanometer or million electron volt into femtometer. Okay. Similarly, C equal to speed of light 2.998 into 10 to power 8 meter per second. Electronic charge E equal to 1.602 into 10 raised to the power minus 19 coulomb. Okay. For the time being, we skip this table because this table has been included several times in our previous problems. Okay. Next table is about particle masses. Okay, dear students, in this table masses of various particles are given. Okay, not only in terms of atomic mass unit but also in terms of kilogram, in terms of million electron volt over c square. Okay. Particles whose masses are given are electron, muon, proton, neutron, deuteron, alpha particle. Okay. Dear students, here it is important to point out here that mass of muon is given here 105.66, while in the statement it is given as 106 million electron volt over c square. So no difference. Okay. 105.66 can be approximately written as 106. Okay. So the purpose of showing this table is that even if mass of muon is not provided in the statement, we can get that mass from here. Okay. Similarly, we may take other value from here like this 938.27. Okay, mass of proton 938.27. Okay. Dear students, next snapshot is about reduced mass. Okay, reduced mass of a diatomic molecule Mr, where R is written as a subscript of M, is equal to M1 M2 over M1 plus M2. Okay, where M1 is mass of atom number 1 while M2 is mass of atom number 2. Okay. Next, this is the alternate version of the above snapshot. Okay. A slightly different wording has been applied here because this snapshot has been chosen from some other book. Okay. Reduced mass of proton electron system. Reduced mass of proton electron system M equal to MEMP. Okay, where E is written as a subscript of M because E standing for electron, that is mass of electron, into MP where P is written as a subscript of M, that is mass of proton. Okay, mass of electron into mass of proton over mass of electron plus mass of proton. Okay. Next, dear students, there is an expression for radius and Bohr radius. Okay. Bohr radius Rn is equal to 4 pi epsilon naught n square h cut square over me square. Then a triple line. This triple line is read as, is indicated as, is understood as, is defined as, or is equivalent to. Okay, Rn equal to 4 pi epsilon naught n square h cut or h bar or h reduced. H cut or h bar or h reduced means Planck's constant h divided by 2 pi, okay, over me square, is defined as or is equivalent to n square a naught, where the Bohr radius a naught is given by a naught equal to 4 pi epsilon naught h cut square over me square. Here, next, alternate version of the above definition is given a naught equal to epsilon naught h cut square over 4 over pi me square Bohr radius. Okay, what is the difference? Okay, dear students, here difference is that in the first expression h cut or h bar or h reduced has been used, while in the second alternate version h cut or h bar or h reduced has not been used, while pure Planck's constant h has been used. Okay, now we move forward. There are yet two more snapshots. Okay, next snapshot is En equal to minus E square over 8 pi epsilon naught Rn. This is alternatively becomes equal to En equal to minus E square over 8 pi epsilon naught Rn. This alternatively becomes equal to minus E square over 8 pi epsilon naught A naught n square. This is defined as or equivalent to minus E naught over n square. Okay. This snapshot has been chosen from the book, I think, Modern Physics by Kenneth S. Crane. I think. I am not very much sure. My opinion is. Okay. The lowest energy state n equal to 1 is E1 equal to minus E naught, where, okay, dear students, when we put n equal to 1, then minus E naught over 1 square will be 1, and 1 is divisible by every number whether it is written or not. Okay, where E naught is equal to E square over 8 pi epsilon naught A naught. This is equal to E square over 8 pi epsilon naught into me square over 4 pi epsilon naught h cut or h bar or h reduced square. This is equivalently equal to me4 divided by 2 h cut square into 4 pi epsilon naught whole square, and this is equivalently equal to 13.6 electron volt. Okay, dear students, all these 4 or 5 expressions are equivalent, and we may apply any one whose factors or parameters are available to us. Okay, next, dear students, next is Coulomb's law. Coulomb's law. From this snapshot we will be able to get the value of epsilon naught, which is used in this problem. Okay, Coulomb's law. Magnitude of electric force between 2 point charges F is equal to 1 over 4 pi epsilon naught, where 4 pi epsilon naught is electric constant into Q1 Q2 mod or modulus value or absolute value or magnitude over r square, where r is the distance between two charges. Okay, Q1 Q2 are values of the two charges, while r square is the distance between the two charges. Okay, square of the distance between two charges. Okay, the constants in above equation are approximately epsilon naught is equal to 8.854 into 10 raised to the power minus 12 coulomb square per Newton meter square, and 1 over 4 pi epsilon naught is equal to k equal to 8.988 into 10 raised to the power 6 Newton meter square per coulomb square. Okay. Yes, students, we can take combined value of 1 over 4 pi epsilon naught in this shape, and we can take separate value of epsilon naught in this prior form. Okay. Now, dear students, we are going to start our solution in a regular manner, in a formal manner. Okay. Above snapshots were just to facilitate us. Okay. So now let us start our problem, our solution of the problem. Okay. Let mu be the reduced mass. Okay. Mu be the reduced mass, while small m be the mass of the muon, which has been provided in the statement as 106 million electron volt over c square, be the mass of the muon, and capital M equal to 938.27 million electron volt over c square, be the mass of the proton. Okay, dear students, out of these three values, first value is provided in the statement, as well as it is also provided in the table which has been included as a snapshot. Okay, the only difference is that in the statement it is given as it is given as complete 106, while in the table included in snapshots it is given as 105 point something. Okay, that is to say approximately equal to 106. Okay. Then with mass of the muon, then capital M equal to mass of the proton is given in the table which we have included in our snapshots. Okay, while we have assumed that reduced mass is mu, so first of all, then now we are going to find out the value of mu according to the formula which was shown earlier, as m1 m2 over m1 plus m2. Okay, using this formula we are going to find the reduced mass mu equal to small m into capital M over small m plus capital M. Okay, dear students, by putting these values and simplifying, we will get in the numerator 99456.65 million electron volt over c square whole square divided by in the denominator 1044.27 million electron volt over c square. Okay, dear students, 1 million electron volt over c square will be cancelled from million electron volt per c square whole square. Okay, so we will be left with only 1 million electron volt per c square, and hence our resultant reduced mass mu will become equal to 95.24 million electron volt over c square. Okay, this is one part of our problem. Now we are moving to next requirement. Okay, now we are going to part A. Actually, dear students, that was a compulsory calculation. Okay, actually part A is this which we are now going to start. Okay, part A, using the expression which was included in the snapshots included in this problem. Okay, using A naught equal to epsilon naught h square over pi mu e square. Okay, dear students, all these values are known to us. Okay, value of epsilon naught is given in the snapshot. Okay, in which Coulomb law was defined. Moreover, value of Planck's constant h is given in the table which we included as a snapshot. Moreover, value of pi, we know that pi is 22/7 and it is taken as 3.14. Okay, pi is a very special number. Its decimal representation goes endlessly. It does not terminate at any time. Okay, it is a magic nature number. Okay, pi 22/7, 3, which is usually restricted only up to 2 decimal places, that is 2.14, but in reality in mathematics, it is a very, very, very special number. Its decimal representation goes endlessly. Okay, anyhow, we do not go in this detail. Then, dear students, value of mu we have already calculated in previous step, 95 point something. And then elementary charge, electronic charge, charge of an electron, or charge of a proton, e square. Okay, now hence we are now able to put all these values. Okay, because one value we have calculated in the previous step, while all other values are given in the physical constant tables, which have been included in this problem before starting this solution. Okay, so dear students, I think we should not discuss simplification process. Okay, simplification process, dear students. Mm, okay, quite just simplification. Okay, dear students, if we go in detail of these simplifying steps, it will take too long time. Okay, I think because these simplification process is simple. Only a few conversion factors may be used. Um, Dear students, we move forward. Okay, we do not discuss simplification process. Okay, simplification process, if discussed, it will take too much time. Okay, simplification process, if discussed, it will take too long time, and we cannot afford so long time for such minute purpose. Okay, dear students, it is the simplification is going on, simplification is going on, simplification is going on, and hence our answer becomes 2.85 into 10 raised to the power minus 13 meter. Okay, we go back. We just show simplification steps once again without explaining them. Okay, so dear students, this is Bohr radius A naught, value of A naught after putting all these values in this expression becomes equal to A naught 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 becomes equal to 2.85 into 10 raised to the power minus 13 meter. Okay, dear student, now we are going to part B. Okay, part B, using E equal to me raised to the power 4 over 2 h cut square into 4 pi epsilon naught into whole square. Okay, dear students, we had shown a snapshot in which several alternate expressions were shown, and I had told that we may choose any of these equivalent expressions about which we may have all concerned values. Okay, so we have chosen this style, this pattern, this mode. Okay, dear students, actually the benefit of choosing this style will be that we have a fixed value of expression e square over 4 pi epsilon naught. Okay, so here if we use e square, then e4 will be covered, and 4 pi epsilon naught is already square. So e square over 4 pi epsilon naught into e square over 4 pi epsilon naught. Okay, value of e square over 4 pi epsilon naught is given in the table which we had shown in snapshots regarding this problem. Okay, so taking benefit of this constant value, this portion will be completely solved, will be completely available to us. Okay. Moreover, value of m is also known, and value of value of h cut, h is known, while we can, when divided it by 2 pi, we will get value of h cut. Okay, so dear students, next, just simplification process. Okay, because dear students, I once again emphasize that this is very simple, because this is value of e square over 4 pi epsilon naught is given in the table, which is equal to 1.440 electron volt into nanometer, or million electron volt into femtometer. This value is given in the table. Okay, so using this value, our most of the part will be covered. Moreover, this 2 is this, and this is the value of Planck's constant h, which is in square, and because h cut is equal to h over 2 pi, so 2 pi will also be squared, and hence 4 into pi into pi. Okay, 3.14 denotes pi, but because h cut or h reduced or h bar is in square, so in addition to the square value of Planck's constant, value of 2 pi will also be squared, that is we will have 4 pi square, that is 4 into pi into pi. Okay, so after next, just simplification, just simplification, and after simplification we will get the value of e equal to, dear students, simplification is quite easy, but a lot of hard working has been done by me in typing this problem in math type software. Okay, so dear students, Allah Almighty may give me reward for this hard working. Okay, so E finally becomes equal to, after these simplification processes, after these simplifying processes, our E becomes equal to 2518 electron volt. So our E becomes finally equal to 2518 electron volt, and this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.